on June 19, 1944, amidst the vast expanse of the Pacific Ocean. Every minute, one could witness a burning aircraft plummeting into the deep abyss of the sea. It was a spectacle akin to a blockbuster movie, leaving spectators in awe. The Battle of the Philippine Sea, also known by American pilots as the Marianas Turkey Shoot. If the Battle of Midway, which took place 2 years earlier, changed the entire Pacific theater in just a matter of minutes, marking the beginning of the decline of Japan's carrier forces, then the Battle of the Philippine Sea would be the final nail in the coffin for Japan's last desperate counterattacks with aircraft carriers. The United States was no longer on the defensive. The United States Navy not only won the battle, but also reclaimed the skies, the fleet, and strategic initiative. The Mitsubishi A6M-0, Japan's mainstay fighter since 1940, was once a terror of the sea, bringing nightmares during the early stages of the war. Everywhere it went, it left behind shattered fleets, ruined fortresses, and seas stained red with tragedy. But now, the fighter fleet that Japan once took pride in was being torn apart by the Hellcats born to defeat the Zero. They didn't need to outmaneuver the Zero in tight turns. The Grumman F6F Hellcat only needed to be stronger, more resilient, and capable of shooting accurately from a distance. With thick armor, a cockpit encased in steel, self-sealing fuel tanks, overwhelming firepower from 612, 7mm M2 machine guns, and a powerful, reliable Pratt & Whitney R2800 engine, the Hellcat could return to base even when heavily damaged. When these Hellcats took to the skies, the Zero was no longer a nightmare. It became a live target for American pilots. The Battle of the Philippine Sea did not end World War II, but it extinguished any hope Japan had of victory or even negotiating from a position of strength. Over 600 aircraft were shot down, and experienced pilots suffered heavy losses. It was a blow from which Japan's carrier air forces could not recover. For the United States, this was a glorious victory, showcasing the strength of its naval air forces and cementing the F6F Hellcat's reputation as an airborne assassin. The Hellcat became an icon of American naval air superiority. It was credited with destroying 5,023 enemy aircraft, accounting for more than half of the air victories achieved by the United States Navy and Marine Corps during World War II. How did the Hellcat achieve this? How did a seemingly simple design create the perfect airborne war machine? Let us explore the story of its technical prowess, superior combat capabilities, and the battles that made the Grumman F6F Hellcat one of the most iconic and successful fighter aircraft in United States military history. The birth of the Hellcat, from concept to combat. By mid-1942, United States Navy pilots faced a harsh reality. Their F4F Wildcat fighters struggled significantly against Japan's agile A6M-0 fighters in the skies over the Pacific. The weaknesses of America's primary carrier-based fighter were glaringly exposed in dogfights. The F4F Wildcat was a rugged and reliable aircraft, but it couldn't match the Zero's capabilities. The Zero boasted a higher top speed, greater maneuverability, and a longer range, posing significant tactical challenges for American pilots. Unable to outrun or outmaneuver the Zero, Jimmy Thack, a naval aviator, air combat strategist, and United States Navy admiral during World War II, devised a group flying tactic to compensate for these shortcomings. This tactic, known as the Thack Weave, required at least 2 Wildcats to fly parallel to each other, separated by a few hundred meters. When one was tailed by a Zero, both aircraft would turn simultaneously, each veering into the other's flight path to form an X shape. The pursued aircraft would lure the enemy into the line of fire of its wingman. The enemy, fixated on chasing its target, would become prey for the second Wildcat to shoot down. This clever tactic enabled the Wildcat to perform better in combat, but it didn't address the aircraft's fundamental weaknesses. Moreover, the tactic demanded exceptional coordination between pilots and was less effective when outnumbered, ambushed, or unable to fundamentally resolve the Wildcat's performance deficiencies. Grumman had already begun researching a replacement for the Wildcat even before the attack on Pearl Harbor. The company started developing a new fighter prototype in 1938 and signed a contract for the XF6F-1 prototype on June 30, 1941, 6 months before the United States entered the war. Leroy Grumman, along with Chief Engineers Jake Swerble and Bill Schwendler, worked closely with the United States Navy's Bureau of Aeronautics and pilots who had flown the F4F in early 1942. This collaboration was crucial in creating a fighter capable of defeating the Zero. On April 22, 1942, Lieutenant Commander Butch O'Hare, a pilot who had engaged Japanese forces, visited Grumman's facilities and provided critical feedback on the Zero's performance. 4 days later, WWII instructed Grumman to equip the second F6F prototype with a more powerful engine, the Pratt & Whitney R2800 Double Wasp, an 18-cylinder engine. The engine change marked a turning point. Initially, the F6F was designed to use the 2600 horsepower Wright R2600 Cyclone engine. Grumman had to redesign and reinforce the airframe to accommodate the 2000 horsepower R2800. The performance upgrade was well worth it. One pilot later remarked, "The difference in performance was like night and day." The development of the Hellcat was a testament to America's remarkable engineering and industrial capabilities. The F6F prototype took its first flight on June 26, 1942, and just 6 weeks later, the F6F followed suit. This occurred shortly after the Battle of Midway, demonstrating Grumman's rapid response to lessons learned from combat. Production moved at a breakneck pace. The first F6F took flight in October 1942 and was assigned to Fighter Squadron VF9 in early 1943. The Hellcat went from blueprint to combat in less than 18 months, an extraordinary feat in military aviation. Fighter Squadron VF5 was the first to deploy the F6F Hellcat in combat, launching from the aircraft carrier USS Yorktown on August 31, 1943, to strike Marcus Island. By 1944, the Hellcat had become the primary fighter of United States carrier-based air forces. The seamless transition from design to combat underscored Grumman's expertise and the Navy's urgent need for a Zero killer. One of the F6F project avoided the delays and technical issues that often plagued such endeavors. Thanks to Grumman's philosophy, build an aircraft that pilots can master in a short time. Production kept pace with development. At its peak in 1944, Grumman's factories could produce 1 Hellcat per hour, reaching 644 aircraft in a single month, a record that remains unbroken. By the end of the war, Grumman had built 12 TD-5 Hellcats, giving the United States Navy unchallenged dominance in the Pacific skies. Engineering philosophy, simplicity, and strength. The remarkable combat record of the F6F Hellcat stemmed from a simple yet effective engineering philosophy. The Grumman Corporation shaped modern carrier aviation with an unwavering commitment to building aircraft capable of withstanding the harsh conditions of naval warfare. Roy Grumman's engineering motto clearly reflected the company's philosophy: build it strong, keep it simple, and make sure it works. This pragmatic approach prioritized durability and operational efficiency over chasing maximum performance metrics. While other manufacturers pursued cutting-edge aerodynamics, Grumman focused on creating fighters that could take hits and keep flying. This philosophy was vividly embodied in the Hellcat's deliberate redundancy structure and its built-in backup systems. One pilot remarked that the aircraft's large design provided enough space to incorporate duplicated control systems and critical components as a safeguard against damage, along with extra aluminum and steel to force Japanese cannon rounds to penetrate multiple layers. Years of experience in building carrier-based aircraft had taught Grumman that impressive specs on paper meant little if an aircraft couldn't survive real combat. Grumman's engineers also worked closely with naval personnel, incorporating feedback throughout the development process. This collaboration ensured that the Hellcat met the practical demands of naval warfare, rather than merely looking good on paper. The R2800 Double Wasp engine, heart of the beast. The Pratt & Whitney R2800 Double Wasp engine was the heart of the Hellcat's resounding success in combat. This engineering masterpiece completely transformed the fighter's capabilities. As America's first 18-cylinder radial engine, it became the driving force behind the F6F's legendary performance on the Pacific battlefield. The journey of the R2800 to the Hellcat was a blend of forward-thinking vision and corporate determination. Pratt & Whitney began designing this revolutionary engine in 1936, 3 years before the United States entered the war. When it debuted in 1939, the engine produced 2,000 horsepower, making it one of the most powerful engines in the world at the time. The R2800 Double Wasp was not only powerful but also exceptionally reliable in harsh combat conditions. Pilots knew the engine could sustain significant damage and still function, In the carrier environment, the ability to return with a damaged engine could mean the difference between life and death. The engine's durability stemmed from its air-cooled design. Unlike many liquid-cooled engines, the R2800 used airflow to dissipate heat, with air passing through the engine to cool the cylinders. Since it lacked a liquid cooling system, it avoided risks such as damaged radiators, coolant leaks, or ruptured lines, failures that could be catastrophic in flight. The R2800 could continue operating even if some cylinders were hit, as long as it maintained oil pressure. This was remarkable. With liquid-cooled engines, a single puncture could cause temperatures to spike, quickly destroying the engine. The R2800, however, could keep running despite losing components, a critical advantage in combat, where taking hits was all too common. Its simple maintenance made the engine ideal for naval operations. Mechanics could keep it running on a carrier deck with basic tools, without needing a land-based logistics hub. This reliability was vital during extended Pacific campaigns, where supply lines were stretched thin. The R2800's power output also improved throughout the war, starting at 2,000 horsepower in 1939, reaching 2,100 horsepower by 1941, and climbing to 2,400 horsepower by the war's end. Some experimental versions even hit 2,800 horsepower with enhanced cooling fans. Legendary pilot David McCampbell, the United States Navy's top ace with 34 kills in a Hellcat, summed it up. The aircraft performed well, was easy to fly, and provided a stable firing platform. But what he remembered most was its durability and ease of maintenance. Armor and survivability, the pilot-first approach. Roy Grumman believed that the last part destroyed on a Hellcat should be the cockpit. This conviction became the cornerstone of the F6F Hellcat's design from its very first blueprints. The fighter prioritized the pilot's survival above all else. While other aircraft manufacturers had to balance protection with weight, Grumman's team never compromised on safeguarding the pilot. The F6F Hellcat was equipped with exceptionally thick armor. Grumman installed 212 pounds of armor around the cockpit, demonstrating an absolute priority on pilot protection. This included a bulletproof windshield capable of withstanding direct enemy fire. Grumman's engineers understood that a damaged engine could easily lead to disaster. To mitigate this, they added extra armor around the oil tank and oil cooler. As a result, enemy shots were less likely to ignite fires or disable the cooling system, common causes of other aircraft going down in combat. The cockpit's placement was carefully calculated to enhance safety. It was positioned high on the fuselage, above the main fuel tank, giving the pilot both an excellent field of view and distance from areas most vulnerable to enemy fire. Additionally, the engine and propeller were angled downward by 3 degrees, improving forward visibility during dogfights. The Hellcat's fuel system marked a significant advancement in pilot protection. The aircraft featured a 250-gallon self-sealing fuel tank in the fuselage, enabling long-range missions while remaining safe. In total, the Hellcat had 3 self-sealing tanks, a 60-gallon tank beneath the pilot's seat, and 2 5-gallon tanks in the wings, bringing the total capacity to 235 gallons, more than double that of its predecessor, the Wildcat. The development of self-sealing fuel tanks was a major technical achievement. The United States Navy began researching this technology in 1940, conducting extensive live fire tests in Dahlgren, Virginia. Engineers discovered that bullets passing through fuel created a powerful hydraulic shock effect that could destroy standard tanks. After numerous tests, they developed a multi-layered design capable of withstanding 50-caliber rounds, far surpassing European standards at the time. The clearest evidence of the F6F's durability came from pilots who returned in aircraft riddled with holes. One pilot recounted seeing Hellcats return with much of their wings shot to pieces yet still airborne. Another continued flying after a hole about a meter wide behind your back, severed cables connected to the vertical stabilizer. War records corroborate these accounts. Pilots frequently returned in Hellcats that had more air passing through them than flying around them, and were mostly holes where the fuselage used to be. One resilient F6F landed with approximately 200 bullet holes and was still airworthy. The numbers tell a similar story. Of the 2,062 F6F Hellcats lost during the war, only 270 were shot down by enemy aircraft in dogfights, a testament to how well these planes survived the worst conditions. The Iron Works philosophy may not have produced the fastest aircraft, but it achieved what mattered most: bringing pilots home safely. Wing design and aerodynamics, size matters. The F6F Hellcat stood out with its massive wings, which defined how it operated on carriers and performed in combat, spanning an impressive 42 feet 10 inches. These wings gave American pilots a clear advantage over Japanese fighters. The Hellcat's wings had a surface area of 334 square feet, larger than any other single-engine fighter in World War II. Grumman didn't choose this size arbitrarily. The company aimed to enhance carrier operations. The large wings reduced wing loading, meaning pilots could land at slower speeds. The real benefit shone through in daily operations. Pilots could safely land the Hellcat at 85 miles per hour. In contrast, Germany's Bf-109, with its smaller wings, required a perilous approach speed of 120 miles per hour. This difference in speed often meant the difference between survival and disaster for carrier pilots. Grumman's engineers prioritized practical needs over pure performance metrics. They knew fighters needed sufficient wing area to handle carrier operations, even if it meant flying slower. This showed that Grumman's team saw the bigger picture of how their aircraft would actually be used. The wing size came with a clever storage solution. In early 1941, Leroy Grumman patented the stow-wing folding mechanism, a breakthrough that forever changed carrier aircraft design. Each outer wing panel could fold back along a unique diagonal line. The story behind this design reveals true ingenuity. Company lore recounts that Leroy Grumman used an eraser and 2 paper clips, bending the clips in various ways until he found the perfect folding angle. This simple experiment led to one of naval aviation's greatest innovations. The design worked brilliantly. When folded, the wings aligned with the fuselage, their leading edges slanting downward diagonally. This allowed carriers to hold 50% more fighters, significantly boosting their striking power. The large wings gave the Hellcat a clear edge over the Zero at speeds above 200 knots. It could roll faster, maintain control at high speeds, and dive in ways the Zero couldn't match. Japanese pilots faced a tough choice. The Zero could outturn the Hellcat at low speeds, but exploiting this advantage meant losing the energy needed to escape dangerous situations. Hellcat pilots leveraged their better power-to-weight ratio to climb and dive quickly, maneuvers enabled by those large wings. The wings also made the aircraft more stable when firing. With 650 caliber machine guns mounted in the wings, stability was critical. Pilots said the Hellcat was steady enough to shoot accurately even during fast maneuvers. The Navy's top ace, David McCampbell, praised the Hellcat. He noted that beyond raw performance, it was easy to fly in a stable gun platform. This stability from the wing design helps explain the F6F's astounding 19-1 kill ratio, an impressive statistic meaning 19 enemy aircraft were shot down for every Hellcat lost in dogfights. This ratio underscores the Hellcat's superiority over its adversaries, particularly Japan's Zero. Weapon systems, 6-gun fighter. The F6F Hellcat was equipped with a formidable weapon system, making it a dominant force in Pacific battles. Pilots dubbed it the perfect killing machine due to its deadly arsenal. The F6F-3 variant was armed with 6 air-cooled M2AN Browning 50 caliber machine guns, each loaded with 400 rounds. Japanese aircraft, with their thin armor, stood little chance against this firepower. These guns fired 75 rounds per second, unleashing 64 kilograms of lead into the air. Enemy aircraft often disintegrated under this ferocious hail of bullets. The guns performed best at a range of 300 yards with a 2-degree elevation relative to level flight. This setup created a lethal cone of fire that Japanese planes rarely survived. The Hellcat's large ammunition capacity gave pilots a significant advantage in combat. Each pair of guns on either side held 400 rounds, enough for 32 seconds of continuous firing per gun. With a total of 2,400 rounds, pilots could sustain fire for about 26 seconds. This was a critical factor, as it meant they had more firing time than other fighters. Pilots could stay in engagements longer thanks to this ammunition reserve. One pilot noted that the F6F could tear apart the light and fragile Japanese aircraft. The combination of powerful firepower and ample ammunition made this possible. The Hellcat proved its worth beyond air-to-air combat. Its pilots launched over 60,000 rockets at ground targets and enemy ships throughout the war. This versatility made it a valuable asset for a wide range of missions. Beyond the Zero, taking on advanced Axis fighters. At the end of World War II, the Axis nations introduced improved fighters, making the F6F Hellcat's opponents tougher. These battles proved the Hellcat could do more than defeat Zeros. The Hellcat's most formidable Japanese opponent was the Kawanishi N1K Shiden, officially titled by Japan and produced by the business. Shiden means violet lightning in Japanese. The United States and its allies called it George, adopting their way of categorizing Japanese aircraft. The Shiden was more dangerous to the Hellcat in dogfights than the Mitsubishi A6M0 because to its superior design and performance. By late World War II, about 1944-1945, the United States had built powerful fighters like the P-51 Mustang and F-4U Corsair. The Shiden, especially the improved Shiden Kai, it could match these aircraft in speed, maneuverability, and weaponry. In 1944, the Shiden Kai, an improved N1K, emerged. Changes made the Shiden Kai easier to make and more effective in combat. Roll rate, which measures how fast an aircraft rotates from wing to wing, was 82 degrees per second. This revealed the Shiden Kai could quickly reverse direction in dogfights, giving it an advantage. The Hellcat had a good roll rate, but couldn't equal the Shiden Kai's speed. 4 20mm Type 99 cannons on the Shiden Kai were more powerful than the Zero's two. These guns could damage even strongly armored enemy aircraft like the Hellcat, improving the Shiden Kai's head-on engagement. Despite its excellent qualities, the N1K came too late and in too few numbers to change the war. Shiden fighters on the Japanese front line shot down some American planes. When expert pilots took over, Hellcat-Shiden battles became truly brutal dogfights to the death. The F6F Hellcat excelled against German aircraft, but is most recognized for its Pacific fights. British Fleet Air Arm Hellcats first fought in Europe in April 1944 when they attacked the battleship Tirpitz in Norway. The Hellcat encountered the Messerschmitt Bf-109 and Focke-Wulf FW-190 over Kafjord the following month. Above sea level, the Hellcat and Me-109G were equal, but above 22,000 feet, the Hellcat won. The Hellcat's 36 pounds per square foot wing loading beat the Messerschmitt's 42 pounds in turning fights. Hellcats shot down He-111s, Ju-52, and Do-217s during Operation Anvil Dragoon. British Rear Admiral Thomas Trowbridge said, "American aircraft, particularly the Hellcat, demonstrated their superiority, legacy, and influence. Beyond combat, the F6F Hellcat changed naval aviation for decades. The Hellcat emphasized durability, simplicity, and pilot safety. Grumman's decision to make components twice as strong paid off. After the Hellcat, naval fighters got greater armor and self-sealing fuel tanks. People understood pilot survival was more crucial than performance measurements. Navy aviation design relied on Hellcat maintenance ease. A Grumman engineer said, "A sophisticated aircraft that can't be maintained in combat isn't an aircraft." The piston engine era's naval fighters evolved around this principle. After the Hellcat, these successful design ideas inspired a new generation of fighters, including the F-8F Bearcat. The Bearcat evolved from the Hellcat in November 1943. Grumman used carrier operations experience to produce the F-8F, a smaller aircraft with the same powerful Pratt & Whitney R2800 engine. The revised design weighed 2,000 pounds less than F6F. This weight decrease improved performance greatly. The Bearcat could climb 4,500 feet per minute compared to the Hellcat's 3,000 and reach 424 miles per hour. Professionals consider the F-8F one of the best handling piston engine fighters ever. The F-6F was essential to United States naval strength throughout its service life. Navy Reserve fighter squadrons flew Hellcats after the war. The 1946 formed Blue Angels flight demonstration team chose it as their first aircraft. Final years saw new uses for the versatile Hellcat. Some became radio-controlled drones for Bikini Atoll atomic bomb tests. Other F-6F 5K drones attacked North Korea during the Korean War. The Hellcat flew its last flight in May 1961 at Point Mugu, California. These aircraft are currently in museums, letting future generations to learn about the F-6F Hellcat's impact on naval aviation. Grumman Hellcat, your favorite aircraft? Do you support Grumman's design philosophy? Comment your ideas below. Thanks for viewing, and be sure to like the video. See you next video!